U substitution is basically just integrating a chain rule problem. Okay, it's chain rule backwards. This is really the last integration technique that we're going to look at. Okay, the rest of the year then is just going to be applications of integration. So we're going to spend a few days on this because there are a lot of different cases that we'll have to look at. But the essential idea is just undoing chain rule. So the key when we're doing a U substitution problem is to find an application of chain rule, to find a piece of the function whose derivative is also in the function. And we'll do a bunch of examples here in a second. So, yeah, I guess I could just make up an example and go through it as we go here. So, the substitution method. So let's say we're given something like this. Let's say 2x times x squared plus 7 to the 4th power. Right? So what we want to look for, what we want to recognize is a piece of the function whose derivative or a multiple of its derivative is also in the function. So if I look at this piece, x squared plus 7, what's the derivative of x squared plus 7? 2x. That's there as well. Okay, that's the idea. We're looking for a piece of that function and its derivative. So what we do then, okay, we take that piece, okay, that original piece, and we call that u. So here I'm going to define u as x squared plus 7. Right? Now, I want to take the derivative of u. Okay, I'm ignoring this problem now. I've defined my u to be x squared plus 7. Now, I want to take the derivative of u, okay, and I'm going to denote that du. So the derivative of u here is just 2x dx. Taking the derivative here when we're using u substitution, we do want to tack on our dx. Okay, so that's in this step 1 here. Now, what I want to do is take this integral and rewrite it in terms of u. So, what we have is, so my u is x squared plus 7. So what I would have is u to the 4th power. And then 2x dx, that's exactly what I want, so I would just replace that with du. Okay, so I have done my u substitution now. I've defined this piece to be u. Its derivative, that is du. Now, we can take the antiderivative of this pretty easily, just using power rule. So what would the antiderivative of u to the 5th be? Yeah, 1/5 u to the 5th. Gave you half of what? Okay. So 1/5 u to the 5th plus c, right? Always plus c when we're doing indefinite integration. And then the final step is to substitute u back in. So the actual antiderivative of this would be 1/5 times x squared plus 7 to the 5th power plus c. Well, remember when we integrate, that dx goes away? Same idea here. When we integrate, du goes away. So, the answer to this problem is this. Okay. So if you remember, I promised you we would get to something like this. Right? We'll also eventually get to something like this. Right? What? So, questions so far? Okay, the key is this bottom thing, this pattern recognition. Just being able to recognize some piece of a function and its derivative. Right? So I left the back of this paper blank. I figured I would just make up a bunch of examples. We can do them together here. So let's try another one similar to that. How about 3x squared times x cubed plus 14 to the 8th power. And so, can we recognize some piece of this function and its derivative? What's 3x squared? Yeah, so the inside, the x cubed plus 14, its derivative would be 3x squared. So what should my u be? X cubed plus 14. So I'm going to say u equals x cubed plus 14. Right, du equals 3x squared dx. So now I can do my u substitution. So I would have u to the 8th power, and then 3x squared dx. That's exactly what I have for du. So my u substitution would just be u to the 8th du. So then what's the antiderivative of that? U to the 9th plus c. And then the final step is just plugging u back in. So the actual antiderivative would be 1/2. 1/9 x cubed plus 14 to the 9th power plus c. Feeling okay so far? Alright. Let's add in another twist. Come on, that was easy. Let's make it a little harder now. How about x 4x squared minus 3. Yeah, that'll work out. How about this? 2x times 4x squared minus 3 to the 5th power. So, in the examples we've done so far, we saw a function and its derivative. In this one, we don't quite have that. Right? We have the derivative of 4x squared minus 3 would be 8x, right? Not 2x. But all we're looking for is this to be a multiple of the derivative. Okay? It doesn't have to be exactly equal to the derivative, as long as it's a constant multiple of the derivative. So 2x technically is a multiple of 8x, right? There is a number that I can multiply 8x by to get 2x. So this will still work out for u substitution. So what we want to do is say u equals 4x squared minus 3. Take the derivative of u. So du would be, we said, 8x dx. but I don't want 8x dx. I want 2x dx. So we would divide by 4 or multiply by 1/4. Right? Either way we want to think about it. So what we want to say is, I'm going to multiply both sides of this equation by 1/4 to get what I want. So I'm going to say 1/4 du is equal to 2x dx. And now I can do my u substitution. So now I can say that I'll have u to the 5th power times 1/4 du. So I can pull that 1/4 out front. Whenever we have a constant, I can just pull it out front. And now we want to integrate. So what's the antiderivative of u to the 5th? 1/6 u to the 6th. But then I still have that 1/4 out there as well. So I'll have 1/4 times 1/6 u to the 6th plus c. And then I could go ahead and multiply this 1/4 and 1/6 together. And I'll do that in one step as I plug my u back in. So this will be 1/24 times 4x squared minus 3 to the 6th power plus c. You okay with that one? Alright, let's do another one like that. About 10x cubed times how about this? 10x cubed times 10x to the 4th minus 7 to the 20th power. See if you can set this one up here. Feel okay with that one? 1 over 84 times 10x to the 4th minus 7 to the 21st plus c. right, let's try this one. Yes. 8x plus 4 times 2x squared plus 2x minus 3 to the 6th power. So we recognize some function and its derivative within this, or a multiple of its derivative. So my u plus 2. Right. So I get my du to be 4x plus 2, but I want it to be 8x plus 4. So I would have to multiply by 2. So I would get 2 du equals what I want. Then I can do my u substitution. I can pull that 2 out front, and I would just end up with 2 u to the 6th du. Then get 2 times 1/7 u to the 7th plus c. So 2/7 times 2x squared plus 2x minus 3 to the 7th plus c. Feeling okay so far? Alright, how about something like this? About x over
We've just taken that.
yes. Okay, that's the key for something like this. I would just want to rewrite this, make this a negative 4th power. Right? If I see this in the denominator, I can just say, well, this is the same thing as 5x times 10x squared minus 3 to the negative 4th power. And then it looks pretty similar to what we've been doing. Right? So when we see a fraction like this, okay, just make that exponent negative. So see if you can finish this one out here. Get negative 1/12 times 10x squared minus 3 to the negative 3rd plus c. Alright, one more. about x times the square root of, how about this? X times the square root of x squared minus 3 dx. How would I approach something like this? Yeah, just rewrite it as the 1/2 power. Alright, so on this sheet, don't do the last one, just 1 through 13. And there are a few of these where it would probably be easier to not use U substitution. So make sure that you can differentiate between recognizing where we have a piece of the function and its derivative and where we do not. Okay, so on a couple of these, you won't use U substitution. The majority you will, but a couple you will not. So numbers 1 through 13.